The team applied the HF guidelines to a gas plant design project in early 2015. In this case, human factors engineering was requested by the client and provided an excellent opportunity to test the approach and guidelines in practice, particularly in terms of gaps in the methodology and improvements in the progress of the design. In order to perform the basic ergonomic review regarding accessibility and maintainability of equipment, a basic ergonomic review using 3D model was performed in the case study. The 3D model review took place at 3 different stages of development as 30%, 60% and 90% stage of development of project. A structured methodology was provided explaining the team and members involved, plus a checklist for ergonomic aspects to be looked at. The first step is to acquire the 3D model from the design team. This model is developed to review technical elements of the design and can be reused for HFE purposes. Technical and HFE reviews of the 3D model can be conducted in the same workshop, either as one group or in separate groups to achieve time saving. The workshop should include stakeholders representing end users, engineers and human factors specialists, and together review the model unit by unit to identify accessibility, operability, and maintainability aspects of the design. Recommendations of changes to the design are captured and circulated to the relevant engineers for action. These recommendations should be viewed in the next workshop to ensure each has been properly addressed. Here you can see an example of the 3D model used in these workshops. The review in the case study resulted in 268 action items which were brought forward to improve the design. The second example is the alarm rationalization. The objective of an alarm study is to collect the alarms and related information and review them in accordance with the ergonomic principles provided by references such as EEMUA 191. To incorporate ergonomic principles to the design of alarms, a guideline was developed based on available references to inform the process engineering team and incorporate ergonomic principles into the design of alarms. Moreover, an Excel tool was developed to assist the designers in selection of alarm priorities based on the related hazards and the time before the consequences. This matrix structure helps the process engineering team to select the right priority for the alarm in accordance with best practices. During the workshop, the alarms were reviewed and the team checked the clarity of alarm message and the priority of alarms and captured the action items. This resulted in better alarm configuration, thereby making the plant easier for operators to manage and reducing the possibility of error. The results of the alarm rationalization in the case study are shown here. The initial configuration describes the allocation of alarms before the alarm rationalization workshop. This was produced by engineers and represents a significant step forward from previous design projects where most alarms would be unclassified at this stage. The guidelines provided the engineers enabled them to make an initial estimate of the alarm configuration. The second graph describes the alarm configuration after workshop. It can be seen that the critical alarms reduced from 27% to 7%, in line with best practice on alarm management, while use of alerts was better optimized. The introduction of guidelines for the engineers also allowed the alarm rationalization workshop to be reduced by approximately 40% in time, since the engineers were fully prepared and all required information was available to classify the alarms correctly in the workshop. This allowed 200 alarms to be reviewed per day, compared to an estimated 150 alarms per day based on previous project experience. ABB Italy now dictates this methodology across all design projects. Another activity normally overlooked is the setting up of a critical task inventory for the project to be followed up. This is to ensure operating philosophy and manual are feasible human tasks. This requires a screening of the tasks for the plant, which may come from HAZOP,
HSE cases, or operating philosophy manual to be screened in collaboration with the end users to prepare critical task inventory, if necessary, conduct critical task analysis, conduct initial human error alarm review, and review required controls. This will often translate in better error-proof procedures, better device training on hotspots, and whenever possible, the engineering of controls before commissioning. This also delivers to the company an initial potential risk register for operational required activities that could be updated over the time. This work is hugely overlooked till issues become apparent at operational stage. Some of the benefits of the new HFE approach in terms of alarm rationalization example and 3D model review example are shown here. The avoidance of delays and extra workshop days and respecting the deadlines is the main benefit derived from the new approach to 3D model review. Each day of 3D model review has a minimum cost of €3,000. The same benefit was gained during the alarm rationalization by completing the review earlier than planned and therefore saving the cost of 3 workshop days that could be estimated at a daily rate of €3,000. This simply can be defined as €9,000 saving for alarm rationalization workshop and avoidance of the extra €10,000 cost for 3D model review. In terms of the recommendations and the input provided by HFE team for the projects, it is difficult to provide concrete cost effectiveness evidence. However, the impact of the HFE input can be summarized in terms of broad benefits. For example, the impact of recommendations from the 3D model review can be categorized as extreme, as shown in the table, as the cost of making these modifications when the plant is operational is prohibitive. There are also benefits in terms of providing for safe operation and reducing the probability of error in operations. A design process that is tied to HSE and HFE activities can help the project managers to better plan and organize the required design activities and avoid delays. Thank you.